Okay, so when you're doing word problems, you have to be able to kind of figure out what are the two things that you were talking about. So when you see this systems of equations, you should know that systems of equations has two different equations, and then you choose how you want to solve them, whether elimination or substitution or graphing. Now if you graph, you don't need to use a piece of graphing paper. You could, but you have a calculator that can do it for you. Okay, so as I look at this problem and I look and I see Donna cashed a check for $265 and asked the teller to give her only $5 and $10 bills. In every system of equations problem, there's basically two things that you're discussing, and in this case it's the type of bill that she'll receive. So going into this, I'm just going to establish what I want to call each one. So I'm going to call X my $5 bills, and I'll call Y my $10 bills, just so I know these aren't the equations you're going to use, but these are the rules that you're setting for yourself as you build your equations. So I'll continue reading. She received 36 bills in all. Okay, so this is how many bills that she received all together. So we already know that there's two types of bills. There's $5 bills and there's $10 bills, X and Y, and the total amount of bills that she received is 36 bills. So that's your first equation. The second equation is going to deal with the value, in this case the money or dollar amount. So she received a total of $265, so that'll be 265, and it was made up of bills that were worth $5, and the $5 bills are X, and they're worth $5, so it'll be 5X, and $10 bills. Dollar bills is Y, so 10Y. And those are your two equations. Now how you solve these depends on how you want to solve them, but I am going to, now I'll do elimination here, just to show you that you can. So I'm going to rewrite these equations, and I like to just rewrite them so that it's neat. And I'm going to stack them above each other. And I'm going to decide, I'm going to cancel out the x's. So I want these to cancel out, so this should say negative 5x. So I'm going to multiply the entire top by negative 5x, and this would become, or negative 5, so this would become negative 5x minus 5y equals, oops, it doesn't equal 36. Let me take out my calculator, and let's just say 36. Whoops. Low batteries yet again. Okay. 36 times negative 5. Negative 180. So this is going to be negative 180. And this equation didn't need anything to be done to it, so I'll go ahead and write it there. And then we're just going to stack them, and we're going to cross out what we hope to cross out. We were looking to cross out the x's, so they're gone. So I'm left with 5y equals 85. And then I'll divide by 5, and I'll get y equals 13. So you're always looking to get two answers. There's an x and there's a y, so you found y. So now that I know that y is 13, I'm going to go back to this equation, and if x plus y equals 36, and I know y is 13, so that means x plus 13 is 36, I'll subtract 13, and I'll get x equals 23. And that's going to be my final answer. 23 $5 bills and 13 $10 bills. So let's do another one here. Okay, so this is the charge for admission to the aquarium is $275 for adults and $150 for children. Okay, so we're talking about two different price points. And so we'll call X the adults, and we'll call Y the children tickets, or the children prices. Okay, so on a day when 589 people paid to visit the aquarium, the receipts totaled $1,151. Okay, so basically there's two types of tickets. There's the adult tickets and the children tickets. So the adult tickets plus the children's tickets will equal 589, because that's how many people visited the park on that day, or the aquarium. Okay, so now the other equation is going to be dealing with the money, and in this case it's nice because you have dollar sign, and dollar sign. So they go together. They should be in the same equation. So that would mean that the adults, which is x, which costs $2.75, so this will be 275x plus the children, which is 150, plus 1.50y equals the amount, $1,151. Now I'm not going to put the dollar signs here just because it makes it a little bit more difficult to talk about, but this is the dollar values that were in our problem. Okay, so now you could try to eliminate like we did here and stack them up, multiply, and then cancel out, and then solve for one variable, then go back and solve for the other one. But the minute I see these decimals, I'm thinking that's not going to be so good. But let's talk about common sense. You know that these answers have to be nice, because you can only sell a ticket or don't sell a ticket. You can't sell like a decimal of a ticket. You can't sell 2.6 tickets. So even though I see decimals here, I know that my answers should be good. And I know I can't sell negative tickets, so I should have all positive numbers. But even then, trying to eliminate this seems like a big headache. So what I'm going to do is I'm going to use substitution. I'm going to take this equation and I'm going to solve for y. And I'll get y equals 589 minus x. Okay, so that's going to be useful. I'm going to circle it for now. But because I know that y is 589 minus x, I'm going to go into this equation and replace this y with 589 minus x. So 2.75x plus 1.50, not going to put y, I'm going to put this instead. 589 minus x equals 1,151. So you just got to be careful when you distribute here that you don't make a multiplication error, but 1.50 times 589, I'm not going to mental math this, I'm just going to use my calculator. 1.50 times 589 is 883.5, and then 150 or 1.50 times a negative x will just be minus 1.50x equals 1,151. You're going to combine like terms. So 2.75 minus 1.50, so this will be 1.25x plus 883.5 equals 1,151. And then you're just going to solve for x like you did back in September. So 1.25x equals, and you use the calculator here to assist you, 267.5. And then the last step is to divide. I'm running out of room here, so I'm going to put my answer over here. 267.5 divided by 1.25 is going to be 214, which is great. We said we were going to have a nice number, and we did. You sold 214 adult tickets. So now this equation that you worked hard to get in the beginning actually turns out to be something of a little boost for you, because you need to solve y, and you have this nice little equation telling you what y is equal to, and you know what x is, so now you can plug in. So y will be 589 minus 214, so now y is equal to 589 minus 214, 375, and that would be the answer. Okay, now if you look down here, it's talking about coins. So coins are different because you have to know how values are written as coin amounts. So let's just talk about the fact that we need to set this up first. There's quarters and dimes. So I'm going to say that X is quarters. Now if it helps, you can use Q and D for dimes if that helps you not get them mixed up. I'm just sticking with the traditional X and Y, but it doesn't really matter what letter you use. It also doesn't matter if you flip these. You want to call quarters Y and X's dimes, it's still going to work out. And so what we're really looking for are the two answers. It doesn't really matter which is which, but it helps if you write it down to begin the problem. So now we know he has 20 coins in total. So our first equation will be some amount of quarters plus some amount of dimes equals 20 total coins. And most systems problems will have a simple setup equation like this, and then the other one will usually involve the rest of the numbers. Now if you look, there's only one more number, and it's dollar amounts. So in the previous example we had 3 different dollar amounts, but in this example you have 1. So this is where coins are slightly different. So this is a little different because now you need to know the dollar amounts, but this is based on prior knowledge that you know with basic money. Quarters are written as 0.25, as in 25 cents. So this will be 0.25x plus dimes, which is 0.10. You can put 0.1, but I like to put 0.10 to show it's 10 cents, times y equals $3.95. Just like the last problem, I see that it's decimals. I'm not really looking to cancel out with elimination. I think I'd rather do substitution here, so I'm going to solve for y again, and I'll get y equals negative x plus 20, or 20 minus x, however you want to do it. So I'm going to take this equation and I'm going to go into the other one and replace the y here with negative x plus 20. So this will now look like 0.25x plus 0.10 parentheses. We're taking out the y and we're going to put in what y is equal to, and that equals $3.95. So now you distribute. You just got to be careful with your signs. This 0.25x, nothing happens there, so we'll bring it down. 0.10 times a negative x will just be minus 0.10x. 0.10 times 20 will be 2, so plus 2, positive 2, equals $3.95. Combine like terms, and these two will be 0.15x plus 2 equals $3.95. And then you solve for x. The fact that it's a decimal doesn't change the fact that you already know what you need to do. So 0.15x equals $1.95. Divide by 0.15, and you will get x equals, I'm going to use my trusty calculator here to assist me, x equals 13. So you have 13 quarters, right? Because x is quarters. This equation is now helpful because it allows you to kind of block everything else out and just use what you know to plug in. So y equals negative x plus 20, so it's going to be negative, and x is 13, so we're just going to sub that in here. So y equals 7. So those 7 dimes and 13 quarters are your answers. Alright, so go ahead and try this one and see what you get for this one.